I think the co-author, and I'm actually the lead author of our comments on which my talk is based, Kevin Diaratna, is here, and is going to be handing out some charts. I won't be using PowerPoint. You can have these to distract you while I'm trying to talk. And usually I have nice, funny pictures that I use in my presentation, so I'm really hoping you did not have decaf this morning. The social cost of carbon is a measure, supposedly, of the incremental damage that an additional ton of carbon emitted will do over the next 300 years, if you're looking at the calculations made by the EPA in their social cost of carbon estimates. So you get a different social cost of carbon for each year. All right? What they say is, suppose we don't do anything about carbon emissions, and we emit one more ton or one fewer ton in 2020. Okay, how much difference would that make in temperature change in 2021, 2022, 2023, out to 2300? Then they say, okay, with that temperature change, how much difference will that make in GDP and sea level rise, and what kind of economic damage will that cause? And as has been pointed out, that's, should I be talking to this one? Does that work? Okay. As has been pointed out, the damage function, that is, the function that translates sea level rise, temperature increase to economic losses, is totally bogus. I mean, the argument should be done at this point. We should say there is no justification for using the social cost of carbon calculations, because right now it's just an academic exercise. If we knew what that damage function was, if we knew what the impact of warming was, then this might be a cool way of calculating the social cost of carbon. We don't even know if it is damage or benefit. Okay, and I'll show you that in a little bit. What you have before you, if you start in the front, it says comments on the social cost of carbon, and Kevin Diaratna, who's passing this out, is the mathematician modeler that we're very lucky to have at Heritage. In fact, those of you that are conservatives should be glad he's on our side. We have run the EIA energy model because Kevin can do it, and then when we're looking at the social cost of carbon, we got two of the three integrated assessment models on which the EPA social cost of carbon estimates are based. The third model, the Chris Hope's Page model, is proprietary, and he insists on having the right to be a co-author on any publication using it. So that seemed like a totally unreasonable burden. So we're just doing the other two, the fund model and the DICE model. The first one we ran, it runs faster, is the DICE model. That's William Nordhaus's model up at Yale. It's one of the three, again, that the EPA uses. We were pretty able to replicate the EPA's results. All right. So again, let me emphasize, the whole thing should be shut down because of the damage function, but the EPA seems to be totally immune to that reason. So we're saying, okay, if you're still going to play with this model, let's look at what happens when we make reasonable adjustments to a few variables, and in some cases, a mandated adjustment to a few variables. For instance, the EPA has been noted only use 3 discount rates, 2.5, 3, and 5. The OMB mandates that you use 2 discount rates, 3 and 7, to bracket the damages and costs and benefits. Okay. They allow you to go outside that if you can make a case. All right. So the EPA did not use the 7%. The Intergovernmental Working Group didn't use the 7%. We can see what happens if you do use the 7% to one of these models, and you would have similar impacts. So if you want to look at that first table, and we can look at discount rate 3%, which is the one that they mainly focused on, in which they generated their social cost of carbon, that is the group, and look at the discount rate for 7 and see how much it changes. For 2010, it goes from $30 down to $4. For 2020, it goes from $37.79 down to $5.87. Okay, so this is close to an order of magnitude change. And the 2050 value is from $61 to $12. That's huge. What does that say? All right. If they had used one of the two discount rates that they were obligated to by the OMB directives, all right, there would have been a factor of almost 10 in the difference between the values. Would have dropped by 80-some%. Okay, factor of 5. All right. So that's just one variable that we changed, using the one discount rate that they were obligated to use, which they didn't use. It makes you wonder why they didn't use it. Now, let's talk about that discount rate. There's been a lot of intellectual gymnastics to push, I apologize about that, to try to justify what I consider ridiculously low discount rates. And what you'll see is the lower the discount rate, the greater the weight is placed on future costs. Okay. One of the arguments is, well, we shouldn't be using a rate of return on capital because we're changing consumption here and consumption there. And if you're changing, that just doesn't make sense to me, because if you're using consumption, if you look at what the interest rate they're paying to consume earlier, it's much greater than rate of return on capital. So you should use a higher discount rate. They fall down, they say, well, what we're really looking at is we have, in essence, a social welfare model. We're saying how much wealthier are people in the future, which they acknowledge, and how much less valuable is another dollar to a wealthy person. That's the only thing that should count, and that's where you get these arguments for 1% and 2% discount rates. It just don't make sense. One of the strongest ones, and it even was in Science last summer, there's been a literature since Martin Weitzman of Harvard published his paper on how should we discount the far distant future. And he came up with a very sophisticated model with a totally counterintuitive result that is totally counterintuitive because it is wrong. All right? And when something is that bizarre, you really have to look at it. But his math is so sophisticated, I think the vast majority of policymakers and even economists didn't really work through it to see what he was saying. It starts out as nominally reasonable. All right? Suppose we don't know what the discount rate should be for the next 300 years, which is a pretty good assumption. All right? For instance, suppose it could be 1 or 7% with equal likelihood. And this is the example they used in Science magazine. What they do is they say, what's $1,000 in 300 years worth today? At 1%, it's about $50. If you discount it at 7%, it's 0. It's 0.0000, I don't know, 5 or 6 zeros, 1.5. All right, so it's nothing. Okay. They then said, what if there's an equal chance of there being a 7 or 1%? Then we average 0 in with 50, we get 27, 25, okay. It sounds like what they're saying is there's an equal chance of 1 in 7, and so you get this, and so we should really be using something closer to the 1% discount rate. What they're saying is we have two possibilities. It is 1% for 300 years straight, or it is 7% for 300 years straight. Now, if there's an equal chance of it being 1 or 7% for each of those 300 years, all right, there are the odds of it being one of those for 300 years straight is 2 times 10 to the minus 90th, minus 90, okay. So they have taken two extreme cases, each of which is almost certain to not happen, and taken an average of that. In order to get this $50, in order to get this $50 present value from this exercise we're talking about, where there's an equal chance of 1 or 7% being the legitimate thing, you have to have it be that 1% for 300 years. All right. To get that present value of $1,000 in 300 years to be as high as $1, that 1% discount rate has to hold for at least 232 of those 300 years. All right. The odds of that, if there's an equal chance, is 10 to the minus 22. Okay, just not going to happen. All right. What do they then do? In order to try to get themselves out of this horrible mess that is simply their model is going to collapse, they say, well, it's possible that we could have correlated discount rates. If you get into a slow growth mode, it might just hang around. We don't know what the future is going to be. It's almost like we've already invented everything, so we can't have growth anymore. The predictions that have been made for centuries. But let's just say maybe. Okay, maybe that's going to happen. What sort of world would we have where the discount rate would be as low as 1? Well, let's go back 2 centuries, okay, and see. From 1802 to 2002, the real rate of return on the stock exchange in New York was 6.8%. Okay, so that would be the opportunity cost of capital for the past 2 centuries, about 7%. Okay. What was the growth rate in the US? The per capita GDP growth rate for those 2 centuries was, let me have it down here, 1.55%. Okay, so keep that in mind. 1.55% per capita GDP growth rate corresponds to a 7% opportunity cost of capital. All right. Now, the world growth rate was even slower. It was 1.1% over those 2 centuries, and I get that from Angus Madison's amazing project. Okay. What are the projected economic growth rates in the models used by the EPA? All right. Now, here we have, it's a bizarre sort of situation. The greater the economic growth, the richer people are in the future, the more damage you're going to get from a percent change in GDP. So you have what may be counterintuitive, that the richer people are in the future, the more growth we have, the higher will be the social cost of carbon. Okay, so what will you then, so you're going to have these bigger, the faster the growth rate, the faster the economic growth rate, the bigger the future damages because you have a bigger pie that you're mucking up. All right. If that's true, you cannot then say, we're going to use a discount rate that corresponds to a world that's stagnant. And that's exactly what they're doing. All right? If we have a stagnant economy, we're not going to have huge damages in the future. You need to align the economic growth rates with the opportunity cost of capital and consequently the discount rate you're going to do. The EPA did not do that. The arguments that Weitzman makes and his whole literature totally ignores that. They say, let's pretend we're going to have fast economic growth. Let's use a discount rate that corresponds to stagnant economic growth. Okay. That said, let's look what happens when you use a more reasonable one. I think 7% should be the minimum discount rate. I don't think it should be the high end and the low end, then we pick something in the middle. All right. Opportunity cost of capital corresponding to a lower economic growth rate than they have in all 5 of their economic models in the integrated assessment models is significantly higher. So it should be more than 7%, but let's just look at what happens. So for the DICE model, we saw using just the 7% discount rate drops the numbers by about 80%. They also came out, they used these integrated assessment models. It's funny, and maybe Pat talked about this. There was a window where some people were making a legitimate case that sea level rise was going to be much faster than had been in the previous IPCC report and in previous literature. Instead of the 7 to 23 inches, it might be as high as 36 or more inches. Right? That was the what was it? The semi-empirical modeling, something like that. Since then, that's pretty much been trashed. We're back to the low ones. Okay. So there's this window of opportunity where they could force the integrated assessment models to use a higher sea level growth. There was also at that time available, all right, lower, newer, better estimates of the equilibrium climate sensitivity. That is how much a doubling of CO2 will raise world temperatures. They ignored that, used the older, higher one. So to me, there's clear cherry picking going on here. Anyway. So what if we used a shorter time horizon, for instance? And if you look at the second table, you can see that that really has an impact on the lower discount rates. Because if you say, let's not pretend we can do economic impact studies for 300 years. I mean, no, come on. We've missed every turn in GDP in the past decade. That drops it dramatically. What if you use the newer equilibrium climate sensitivities, it lowers it even further. So that's the DICE model, what we see there. Okay, so what I've done is I've tried to make an argument that 7% is a much more reasonable discount rate than 2.5, 3, or 5. Okay, and if you use that, not only is it more reasonable, but it's mandated by the OMB. All right, you get the social cost of carbon drops by 80%. You can drop it another couple of bucks if you say, why don't we just pretend we can look out to 2150? Why are we pretending we can look out to 2300? Do we really know how to help people 3 centuries from now? I often think, what if we go back 3 centuries? What would we have wanted our ancestors to do? What would we have wanted them to give up? What would we want them to do for us? When they thought they were doing a public good, it was draining swamps, all right, with going on crusades or things like, things we think are horrible now, okay. Why we think we're going to be so much smarter that we can help our descendants who will be much richer, much smarter 300 years from now. Now let's look at the fund model. Flip the page over. All right, I think maybe we should do jumping jacks now to get get things going. The fund model is the only one that explicitly allows for a negative social cost of carbon. But that means there is a benefit of carbon. There's a benefit from warming, there's a benefit from CO2 fertilization, which we just saw examples of. Okay? The fund is the only one that does that. What do we do there? If you add the 7% discount rate to the fund model, that's all. We're not messing around with a damage function that we think is totally bogus. Okay. Well, now you don't even know what the sign is going to be. For the first 3 decades, the sign of the social cost of carbon is in fact negative. Okay. If you use the new equilibrium climate sensitivities from Otto et al., by the way, the authors, Otto et al., includes most of them are ICC authors as well, ICC report authors. Okay, ICC, Intergovernmental Climate Change. IPCC, thank you, not the Interstate Commerce Commission. So they line up. These can be called denier scientists, all right, or even skeptics. Okay, and I would call skeptic as a synonym for good, but anyhow. Like Pat here, whose predictions 10 years ago, it turns out, are pretty much right on line, and the global warmists are really embarrassed because every time they adjust theirs, they get closer to what Pat said 10 years ago. But in any event, so Otto et al. Are getting closer to what the truth is, closer to what Pat said 10 years ago. We use that equilibrium climate sensitivity, the estimate of how warm it will get for a certain amount of CO2 emissions, and the 7% discount rate. What happens? It's negative all the way down. All right, we should be subsidizing coal. All right. Now, Heritage is not going to come out in favor of subsidizing coal. All right. We still like free markets. But that's what this tells us. If you believe these models, then this says we should subsidize CO2 emissions somehow because it fertilizes crops, because warm is actually better for a lot of people. All right. Now, here I think is the best of the tables. All right. And this was, as was most of this, Kevin's idea and Kevin's work. He said, what if we look at what's the likelihood that the social cost of carbon would actually be negative in the fund model? Because when you're looking here, you see little tiny negative numbers and big positive numbers. You say, well, shouldn't we average them up? But the distribution is not your normal symmetric distribution. It's kind of bunched up on the low end. Even at the 5% discount rate, for the year 2010, the odds using the fund model and the Otto et al. Distribution, all right, the newer, better, all right, distribution, the one that's more likely to be true, because it's had more recent data, it's averaged in this pause that we're seeing. It's about 50-50, okay? And again, why is that? Because most of the benefits come early, the costs come later. So if you have a higher discount rate, you're not giving that higher discount rate won't weight the future as heavily. So we go to 7%, and it's overwhelmingly negative, 70 to 50% as you go down the column there. All right, the odds are CO2 emissions are good. That's what this tells us. Now, I'm not going to try to make that case. Others have made it. The case I'm trying to make is these integrated assessment models are totally useless for making policy. We don't even know the sign. It's possible that we could spend trillions of dollars in the economy to reduce CO2 emissions, and that reduced CO2 emissions are actually a bad thing. All right? So we're spending money to make a bad thing happen. All right? That's what the negative social cost of carbon policy would tell you. Okay. Well, that's pretty much it. Okay, the main point, the integrated assessment models are useless. The social cost for making policy, interesting academic exercise. Social cost of carbon bounces around. We don't even know what the sign is when you make reasonable adjustments in just a few variables. So this should not be used for policy. Thank you.